So let's play around with these state prices. Suppose, okay, all the state prices are already determined in equilibrium, and let's price many other assets. So here is one exercise about the state prices in the dynamic stochastic environment. The environment is simple. We have 4 dates. Date 0, date 1, date 2, date 3. And yeah, let's keep it simple. Suppose every period there are only 2 possibilities. The economy can either go up or go down. Okay? Consequently, we have 15 nodes in this economy. So there are 15 different commodities in the economy. One period ahead state prices are already given. So these numbers on the branches are 1 period ahead state prices. For example, this price of this potato, the node U potato, is 0.55 units of this potato, the date 0 potato. And the price of this potato, node UUU potato, is 0.41 units of this node UU potato. Yeah? Question? What is the date 0 price of an asset that pays 100 or 10 at date 1, depending on the realized state? So consider an asset that pays you 100 units of potatoes if the economy is up at date 1, or only 10 potatoes at date 1 if the economy is down. What is the current price of such an asset? The price of this potato is 0.55. The price of this potato is 0.4. And therefore, the price of such an asset is 100 times 0.55 plus 10 times 0.4. So 100 times 0.55 plus 10 times 0.4. So far, so good? Question 2, what is the date 0 price of the node UU good? What is the price of this potato in units of this potato? Price of this potato in units of this potato. The price of this potato is 0.45 units of this potato, and this potato, the price of this potato is 0.55 units of this potato. Therefore, this consumption good, the price of this consumption good is 0.45 times 0.55 units of this date 0 consumption good. This is just the law of relative prices. If €1 is 0.45 dollars and $1 is 0.55 pounds, then €1 is 0.45 times 0.55 pounds. So far, so good? Yeah? I don't want to give this kind of example. You are supposed to come up with these simple examples when you're studying, because studying difficult things is always about simplifying the problem without compromising the essence. Okay, what is the date 0 price of an asset that pays 1? So the next question, what is the date 0 price of an asset that pays 1 unit of consumption good at date 2, if and only if the date to realization is D? This asset, the payment of this asset is 0, 1, or 0 or 1. This asset will pay you 1 unit of consumption good if and only if the date to realization is D. The price of this potato is, in units of date 0 goods, the price of this potato is 0.55 times 0.48. The price of this potato is 0.4 times 0.46. If you sum them up, that's the price of this asset. Okay? So that's 0.55 times 0.48 plus 0.4 times 0.46. Okay? And finally, what is the price of the node UDD good in units of date 0 good? Node UDD good is this. So the price of this potato is 0.55 times 0.48 times 0.44 units of this potato. Now at this point, I can imagine that probably 1/3 of you have started to believe that these numbers are sort of probabilities, but they are not. They are not probabilities. There's no probability in this question. These are prices. Okay? Now speaking of probability, we introduced this concept of risk-neutral probabilities in the last class. So state prices do not sum up to 1, but 0.55 and 0.4 do not sum up to 1. But if you divide them by own sum, then they sum up to 1. The state prices divided by their own sum are called risk-neutral probabilities, despite the fact that they have nothing to do with actual probabilities. Have you ever heard of risk-neutral probabilities maybe from your futures and options class? Yeah? Okay. So the idea is that the asset price, let's consider again the asset that pays 100 or 10 depending on the realized state. The price of such an asset is quantities times prices. Or equivalently, the price of such an asset is the expectation of the payoff with respect to this risk-neutral probabilities discounted by the risk-free rate. Okay? This is the inverse of the risk-free rate. So it's a tautology, kind of. But you can see that they are the same. Mathematically, they are the same. Okay? Good. Now in this next question, in the next diagram, again, let's assume that there are only 4 dates, date 0, date 1, date 2, and date 3. And at each period, there's only 2 possibilities, up or down. Now the difference is that prices, in the former diagram, the prices, all the future state contingent prices were given in units of, they were 1 period ahead state prices. But in this diagram, all the prices are in units of the date 0 good. So the date 0 good is the numerator for all prices. It's normalized to 1. So this 0.084 means that the price of this potato is 0.084 units of not this potato, but this potato. Okay? All the prices are in units of this potato. But the amount of information is the same. For example, what is the price of the consumption good, the node UU consumption good in units of node U good? The price of this node UU good is 0.12 over 0.4, that's 0.3, 0.3 units of this consumption good. It's the same as, again, it's the law of relative prices. If 1 euro is 0.12 pounds and $1 is 0.4 pounds, then 1 euro is 0.12 over 0.4 dollars. Okay, so the amount of information we have is the same. So that's the answer to the first question. Second question, is the difference between the first diagram and the second diagram okay? Yeah? Good. Yeah, usually the amount of information is the same, even if all the currency prices, Canadian dollar, Australian dollar, US dollar, euro, all the prices are in terms of British pounds. Or, Canadian dollar is 1.2 Australian dollars and 1 Australian dollar is 1.8 euro. The information is the same. What is the node U price of the node UUD good? So what is the price of UUD? The price of this potato in units of this potato. Again, you take the ratio 0.024 over 0.4 equal 0.06, and that's the price of this consumption good in units of this consumption good. And the last one is almost the same. So let's continue after a 10 minutes break. So every year some students say, look, this is far from actual finance. I want to work in the financial sector and this is not relevant. If you think that way, you are very mistaken. Okay, if this one period is like 1 year, then I must say that this is a very rough approximation of the reality. Anything can happen within 1 year, and the state of the economy in 1 year period can be very, very good, or very good, moderately good, so-so, a little bad, very bad, extremely bad. So even in a rough approximation, you would want to allow for maybe 20 or 50 possible states in 1 year period. But if this is much shorter time period, like one week or 3 days, then allowing for only 2 possibilities is not very bad approximation. The economy will slightly go up or slightly go down. So what practitioners do is to allow for many, many dates, like 50 dates or 100 dates within 1 year, so that each period will represent like 1 week or 3 days. Okay? And in each period, there are only 2 or 3 possibilities. Slightly go up or slightly go down, or up or down or remain. Okay? And in the field of option pricing, such massive binomial tree can give you very good approximation of reality. Okay? Okay, so far, these state prices were sort of random. There were no patterns for these state prices. But in practice, usually they make an assumption so that these state prices or risk-neutral probabilities will have some simple patterns. And that's the example we are going to look at in the next example. So in the next binomial tree, we assume that 1 period ahead state prices have some pattern. In particular, we assume that one period ahead state prices can take only 4 possible values, rho UU or rho UD or rho DU or rho DD. Suppose at date 1, the state is up. Then the price of this potato, node UU potato, is rho UU units of this potato. Okay? And this rho UU, you see this rho UU not only here, but also here, 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 here. So the idea is that as long as the current state is U, and the next state is also U, the one period ahead state price is rho UU. Similarly, you see rho UD here, 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 or here. So the assumption is that as long as the current state is up and the next state of the economy is down, the one period ahead state price is rho UD. So that's the pattern we assume here. So in general, rho IJ is the one period ahead state prices, I is the current state, and J is the next state. If we have such simple patterns, then we can price more complicated asset. So let's first consider, oh, by the way, these two diagrams, the top diagram and the bottom diagram, are almost identical. The only difference is the initial state. The initial state can be up or down. So in the top diagram, the initial state is up. In the bottom diagram, the initial state of the economy is down. That's the only difference. The rest is the same. Okay. Question 1. What is the date zero price of an asset whose payment is either DU or DD? So D stands for dividends. What is the date zero price of this asset whose payment is either DU units of potatoes or DD units of potatoes at date 1, depending on the date 1 realization? So consider an asset that pays DU units of consumption goods here and DD units of consumption goods here. Let me switch the microphone. Okay. So this asset pays you, actually the asset price, the asset pays you DU or DD depending on the current state, depending on the date 1 state. The price of this potato is rho UU. The price of this potato is rho UD. So if the initial state is up, the price of such an asset is rho UU times DU plus rho DU times DD. Okay? So yeah, so actually the answer depends on the initial state. So suppose date 0 state is up, then the price of this asset is rho UU times DU plus rho UD times DD. If the date to the state is D, the price of this asset is slightly different. The dividend will be the same, DU or DD, but the price of these potatoes are different. They are rho DU and rho DD. So the price of this asset is rho DU times DU plus rho DD times DD. Yeah, we can rewrite it. In the matrix form, this is rho UU rho u d rho du rho dd times the dividend vector. So this part is what we expressed as P before. So the answer to this question is P times du dd. Okay, but understand what we are doing here. It's just this idea, any asset is a basket of many future state contingent goods. So the price is just the value of such basket, and we are just practicing that. Okay? Question 2. What is the date zero price of an asset that pays 1 unit of consumption good at date 2 if the date 2 economy is up? What is the date zero price of an asset that pays 1 unit of date 2 good if the date 2 realization is down? The answer again depends on the date 0 initial state. The initial state can be up or down. The answer depends on that. This asset pays you. This asset pays you one here, no potato here, one here, or no potato here at date 2. So this asset is the portfolio of 1 unit of this potato and 1 unit of this potato. The price of this potato is rho uu times rho uu. The price of this potato is rho ud times rho du. And that's the answer to the first question. But the answer depends on the initial state. If the initial state is down, the payment is the same, but the price of this potato is now rho du times rho uu, and the price of this potato is rho dd times rho du, and that's the price of this asset. Okay? So that's rho uu plus rho uu times rho uu plus rho ud times rho du. Or, if the initial state is D, the price of such an asset is rho du times rho uu plus rho dd times rho du. The question is almost the same, even if the payment is made at date 2, when the state is economy is down. In that case, the payment of the asset is 0, 1, 0, 1. So it's a portfolio of this potato and this potato. The price of this potato is rho uu times rho ud if the initial state is up. And the price of this potato is rho ud times rho dd. Similarly, if the initial state is D, the payment is 0, 1, 0, 1. So the price of such an asset with such payment is rho du times rho ud plus rho dd times rho dd. Okay? It's tedious, but it's a preparation. So there are 4 possibilities. what is the price of an asset that gives you 1 unit of potato at date 2 when the date 2 economy is up. That's either this or this, depending on the initial state. What is the price, current price of an asset that gives you 1 unit of consumption good at date 2, if and only if the date 2 economy is down. The price of such an asset is either this or this, depending on the initial state. And if you can check, this is actually equal to our P matrix squared. So P matrix is this. Yeah, if you compute P times P, you will get this. And this is actually the 2 period ahead state prices. That is, today you want to buy 1 unit of consumption good. You want to have 1 unit of consumption good at date 2. When the date 2 economy is up, what's the current price for that? You want to have 1 unit of consumption good at date 2. When the date 2 economy is down, what is the price for that today? Okay, this matrix will give you the answer. 2 more questions, 2 more questions, be patient. What is the date 0 price of an asset whose payment, only payment is DU or DD at date 2? What is the price of an asset whose payment is DU or DD? Dividend is either DU or DD at date 2. If you want to have 1 unit of potato at date 2, when the date 2 economy is up, the price is this, if the initial state is U. If you want to buy 1 unit of potato, if you want to have 1 unit of potato at date 2 when the date 2 economy is down, this is the price. Okay, suppose the initial state is U. And this asset will give you DU units or DD units of potatoes at date 2, depending on the date 2 realization. So the price of such an asset should be this times DU plus this times DD when the initial state is U. If the initial state is D, if you want to have 1 unit of consumption good at date 2, when the date 2 economy is up, this is the current price. And this stock will give you DU units of such consumption goods. If you want to have 1 unit of consumption good at date 2, when the date 2 economy is down, this is the current price, state price, for such an state, and this asset gives you DD units of such potatoes. So this is the answer. And this is actually equal to, you can check that this is actually equal to P squared times the vector of dividends, payments, DU and DD. It looks complicated, but it's just summing up quantity times price. It's summing up, that's the asset price. As long as you understand that basic idea, that's the most important part. Okay, this asset is an asset that gives you, so payoff of this asset is DU or DD, depending on the date to realization. Okay. Last question. what is the date zero price of a stock whose dividend is du or dd every period forever. So consider a stock that will keep paying du or dd depending on the economic condition, but every period, forever. Today, the economy is up, you get du units of potatoes. Next period, the economy is down, you get du units of potatoes. Imagine such a stock. What is the price of such a stock? Again, the answer depends on the current state, initial state, u or d. Suppose the initial state is u. What is the price of such a stock? Next period, the economy can go up or go down. If the economy goes up, you will immediately get dividends du. The stock price will be again SU. And the reason is because nothing will change. At date 0, state is u. Or at date 1, state is u. The future is the same. Okay? If the economy goes down in the next period, you will get dd units of dividends, and the price of the stock will be SD. The state prices are rho UU and rho UD. So the price of this stock is rho UU times DU SU. Actually, let me write down. Let me write something more here. Plus, sorry, du plus su plus rho ud times dd plus sd. What is the price of such an asset if the current state is down? In the next period, there are two possibilities. The economy can go up or go down. If the economy goes up, the dividend will be du, the stock price will be su. If the economy goes down, the dividend will be dd, and the stock price will be sd again. If the current state is d, state prices are rho du and rho dd. And as such, the price of this stock is rho du times du plus su plus rho dd times dd plus sd. So far so good? Well, you're already lost. Okay. We can use matrix form. SU, SD. The current stock price depends on the current state, and this is equal to rho UU, rho UD, rho DU, rho DD times, so the last one is D, times du dd, the dividend vector, plus su sd. And you can use vector notation. Let's denote the stock price vector as S. This is the one period ahead state prices matrix P. This is the dividend vector, and this is the stock price vector again. So we have S equal P times D plus S. Here, P is 2 by 2. The rest is just 2 by 1. So we have the stock price equal to PD plus PS. Our goal is to find S. So S minus PS equal PD, and therefore I minus PS equal to PD. Here I is identity matrix 1, 0, 0, 1. Therefore, S is equal to, just multiply the inverse from the left. Sorry. Okay, this is the answer. Solving a problem is about expressing the endogenous thing in terms of something that is given by the question. Dividends are given, state prices are given. So as long as we express the stock prices in terms of these things, that's the answer. Now let me give you more intuition about this result. As you might know, this inverse matrix is equal to I plus P squared plus P cubed, this infinite sum. And therefore, S is equal to I plus P squared plus and so on times P times D. And this is equal to PD plus P squared D plus P cubed D, and so on. This part was, we saw this in question 1. This is the current price of an asset that will give you either DD, or DU or DD at date 1. Nothing else. This is the current price of an asset that will give you DU or DD at date 1. This part we saw in question 3. This is the price of an asset that will give you either DU or DD at date 2. And as you can easily imagine, this is the price of an asset that will give you either DU or DD at date 3. So basically, so this is another answer, equivalent. These two are equivalent, okay? But this second one has more intuition because this basically says that the stock price is the discounted sum of all future payoffs, okay? Discounted sum of all future payoffs. Now, you might be uncomfortable about this part, so let me show you that. Okay, this expression is equal to this. The proof is very simple. You know, in high school you learned that 1 plus R squared plus R cubed dot dot dot. R is just one number scalar, and this is equal to what? 1 over 1 minus R, right? As long as the left-hand side converges, this is equal to 1 over 1 plus 1 minus R. You learned that. And the proof is very simple. Let's say X is this entire thing. Multiply R to X, and that's, you have R plus R squared plus, and so on. And then subtract the second equation from the first, and you have 1 minus R times X is equal to, the right-hand side, only difference is this 1. Everything else cancels out. So you have 1 minus R times X equal to 1. So X is 1 over 1 minus R. As long as this infinite sum convergence. Yeah, you got this. You did this in high school. One interpretation, one implication of this is that 0.9999999 forever is equal to 1. So when I was primary school, my teacher said 0.9999999 forever is equal to 1. And I was like, how come? That's never equal to 1. But according to this formula, this is equal to 1. I mean, you cannot find any number between these two. And if you cannot find any number between these two real numbers, then they should be the same. Now the proof, this one, P is a matrix, square matrix, but the proof is almost identical. So let's say X is I times, I is identity matrix, P is another square matrix. Suppose X is this, and suppose the right-hand side is not an infinity. Yeah? Multiply P to X from the left, then it's P times P plus P squared plus P cubed subtract I minus P times X is equal to I. And therefore, X is I minus P inverse. Yeah, that's it. I guess that's it. So I really enjoyed teaching you. Yeah, so keep working, keep learning, and all the best. I'll see you in your graduation. Okay?